Hello, good souls. Welcome back to this channel. And today I'm just gonna introduce you to grade 11 and 12 nature of the roots. So let's just get to it. Okay, grade 12s. Like I said, we're going to talk about nature of the roots, and you learned nature of the roots in grade 11, and now you're in grade 12, and we want to talk about this topic. So, nature of the roots form part of algebra, and it's on your examination guideline. It's very important that you should know nature of the roots. It's quite a revision from grade 11, strictly grade 11, and we really appreciate resources from www.siavula.com. You can go to their site and just get some notes and further interactive exercises that can help you to master this topic. Okay. So let's start. Like I said, we are going to talk about nature of the roots. So before trying to solve any question related to nature of the roots, we have to really understand what the topic itself means, right? So this is nature of the roots. It's made up of two words. It's nature and roots, right? So we want to know the nature of the roots. So the word nature here on the slide, it refers to the types of numbers the roots can be, right? So when we say nature of the roots, we mean the type of numbers that our roots can be, right? That is what we mean by nature of that root. How many types of numbers that root can be, right? So let me also explain what is a root, right? So a root now, it's what you know as the x-intercept, right? So the x-intercept. So how do you get your x-intercept? You lay to y equals to 0, then you solve for x. So when you solve for those x when y equals to 0, you get your x-intercept, and we call those x-intercept our roots, right? So they are called our roots. So now our roots can have three natures, right? That is what we say. They can possess three types of numbers, right? The first one, they can be real. The second one can be rational. The third one can be irrational or imaginary. So those are the three numbers or types of numbers that our root can be, right? They can be real. Our root can be real. That's their nature. Our roots can be rational, and our roots can be irrational or imaginary. In other words, they can be undefined, right? So that is what we mean when we say irrational or imaginary. We mean our roots can also be called undefined or unknown. So that is their nature. That is what we call the nature of the roots. So I hope you understood that. So for example, if for a quadratic function we have f of x is equals to ax squared plus bx plus c, we know that from this quadratic function, if we want to find the roots, we are going to equate f of x to 0. Then those x-intercept that you get, it's your roots. Then you can actually determine their nature, right? So make sure that before finding your nature of the roots, you have a quadratic equation in that form, right? Because we can only determine nature of the roots only using quadratic equation, right? So we have this quadratic equation. It's in its standard form, ax squared plus bx plus c. So if we want its root, we just equate f of x to 0. So but we know that in order to solve for x, one can then use the quadratic formula. You can see that is the quadratic formula. The one can just use the quadratic formula, x equals to minus b plus or minus root of b squared minus 4ac divided by 2a, right? So within your quadratic formula, you have a square root, right? So inside your square root, you have something, a triangle. Someone can just say this is a triangle, right? So we call that triangle. It's a very important property in your quadratic formula that is very useful for you to determine the nature of your roots, right? So we call that triangle the discriminant, So that triangle is the discriminant, which is equal to, inside the brackets we can see is b squared minus 4ac. So its formula, it will just be basically discriminant equals to b squared minus 4ac, How does this thing help us? So this discriminant, or also called delta, so they can also call it delta or discriminant, its formula is b squared minus 4ac, and we know it's found inside the root of a quadratic formula. How does it help us? So this discriminant is the one that really helps us to determine the nature of our roots. It means it helps us to determine the type of numbers that our root can be. Remember, real, rational, irrational, imaginary, or undefined, right? So if we calculate delta using the formula, then we can be able to predict or to say, okay, this root is real, this root is irrational, and this root is undefined, imaginary, or irrational. So that's it. So now, how do we do so? So there are certain conditions. So these are the conditions that you must really know. Very, very important conditions that you must know in order to answer problems related to nature of the roots. Okay, the first condition, number one, it says if delta is less than 0, that is if your delta is negative, that is less than 0, then the roots are imaginary, or what we call non-real, right? So the roots will be imaginary or non-real, and they are really beyond the scope of this book, right? We won't actually focus on them to say, okay, these roots are non-real and all that. So you just do that in varsity. For now, you just need to know if your delta is less than 0, that is if your delta is negative, then your roots are non-real, what we call imaginary. Sometimes they are called undefined. Right? So that's it. Let's go to the second condition, number 2. If your delta is greater or equals to 0, then the expression under the root is non-negative. Obviously, it's non-negative because our delta is above 0. It's positive, then the expression inside the root there will be non-negative, and therefore the roots will be real. So if your delta is greater or equals to 0, what about the roots? Your roots will be real. So for real roots, we have further possibilities, right? So we have further possibilities. One of the possibilities for real roots is that if your delta is a perfect square, if your delta is a perfect square, and also delta being greater or equals to 0 and being a perfect square, we can further say then the roots are real. Your roots will be real and rational. So that is the further possibility that you can say about your roots, right? If your delta is greater or equals to 0, we said what? The roots are real according to this second point, right? But then if your delta now is a perfect square, for example, you calculate delta and you get 9, right? You get 9. You know that if you take square root of 9, it will give you what? It will give you 3. It means 9 is a perfect square. So we can see delta is greater or equals to 0. Therefore, the roots will be real and rational. Why is it rational? Because our delta is a perfect square. It's a perfect square. 3 squared. So it's a perfect square. So now, let's go to the third condition. If delta is equals to 0, the roots are equal, and we can say that there is only one root, right? So we can say there is only one root. That is, if your delta is equal to 0, you'll see it as we move further in this lesson. What do we mean when we say delta equals to 0? We have one root. I'll just show you in the next page. Okay, let's go to condition number 4. If delta is greater than 0, then the roots are unequal. Why are they unequal? Because we are not saying greater or equals to, right? So we didn't put that equals to there to show that it's greater or equals to. So we just say, okay, the roots are unequal, and there are two further possibilities, right? There are two further possibilities. That is, they can be rational, and they can also be what? Irrational, right? They can be rational or irrational. They can be rational or irrational. We said about them being rational is when your delta is a perfect square. Them being irrational is when your delta is not a perfect square. It's when your delta is not a perfect square, but being greater or equals to, being greater than 0. So yeah, they explaining this further possibilities. Delta is the square of a rational number. If delta is a square of a rational number, if delta is a square of a rational number, the roots are rational, right? If delta is a square, or if delta is a perfect square being greater than 0, obviously the roots will be rational, as I've told you. Then if delta is not a square of a rational number, then the roots are irrational, and they can be expressed in decimal or set form, right? So for example, if you calculate delta is equal to root 2, okay, we can see that this can be expressed in decimal, right? Here it's in set form, but we can also express this in decimal. If you just take as your calculator root 2, and we just get 0.64 for going further like that, right? So you can see that our delta is greater than what? It's greater than 0, but our delta is not a perfect square. This is not a perfect square, right? Because we are getting these decimals here. Therefore, because our delta is not a perfect square, therefore our roots are real. Why are they real? Because delta is greater than 0. But because our delta is not a perfect square, then our root will be irrational, because it's an irrational number. So they are real and irrational. Okay. I hope you understood this. Let's now move further. Okay, grade 12s, let's now move further and talk about nature of the root summary table. And now just in the previous slide, I just gave you some conditions of nature of the roots. If delta is like this, then it means our roots are real. If delta is like this, our roots are irrational, like that, non-real, and imaginary, like that. But you don't really understand what it means and how we can represent this in a graph, right? So this summary table of nature of the roots will actually help you to understand what do we mean really when we say the roots are real, when we say the roots are imaginary, when we say the roots are non-real, and all that, when we say the roots are equal, right? So let's start. If you take a look at this table, we have the first condition, nature of the roots. Our roots can be non-real, right? And we said, how do we know that our root is non-real? We are going to calculate delta, and if our delta is less than 0, we are sure our roots are non-real, right? It is when delta is less than 0. Okay, so when we say the roots are non-real, the other word they can use is imaginary. So they can say the roots are non-real. Sometimes they can tell you the roots are imaginary. Sometimes they can say the roots are undefined. So I'll really like us to explain this using this term. So the roots are non-real, are imaginary, or undefined. What do we mean when we say the roots are undefined? It means that we don't have the x-intercept. Remember I said the roots are the x-intercept. You let f of x equal to 0, then you get your x-intercept. So those are your roots, right? So they are undefined, or what we can call non-real. So if you take a look at your graph here, there is no any x-intercept. We only have the y-intercept there. And also this graph, this quadratic graph, we only have what? We only have the y-intercept. We don't have the x-intercept. To really show that really in these two graphs, the x-intercept or the roots are undefined. We cannot determine them because we don't have them. So that is what we mean when we say the roots are non-real, or when we say the roots are undefined or imaginary. You can just imagine them, but you can calculate them, right? So we say the roots are non-real, imaginary, or undefined because you can't even get them on the graph, right? Okay, so I hope you understood that. Let's move to number 2. They said the roots are real and equal. Okay, so they said the roots are real and equal. So because the roots are real and equal, I'll really stick to this one. The roots are equal. It's when delta is equals to 0. Very important. It's when delta is equals to 0. So when we say the roots are equal, we mean that they are the same, right? So normally it is when you only have one root. So when delta is equals to 0, just know you only have one root. That is when your roots are real and equal, right? So let's really stick to this one, when the roots are equal, right? I'll just change that to say when the roots are equal. So it's when delta is equals to 0. Then on the graph, how will you know it's there? You only have one x-intercept at the turning point. Also in this graph, you can see there is only one x-intercept on the graph. This is x, this is y. So there's only one x-intercept. It is when your roots are equal. That is, you only have one root when delta is equals to 0. That's the condition of the discriminant or delta. Okay, let's move to the third condition. The roots are real and unequal. Roots are real and unequal. What do we mean when we say the roots are real? It's when delta is greater than 0. Unequal, it means we don't have that inequality sign to indicate that they are equal, right? So it's when delta is just greater than 0. We say the roots are real and unequal. So with real roots, we can have two further conditions, as we said also in the previous slide. The roots, if they are real, they can either be rational roots or they can also either be irrational roots. How do we know? So if you calculate your delta and you find that it's a squared rational number or it's a perfect number, let me just say a perfect number. So if you calculate your delta and you find that it's a perfect number, therefore that root will be real, unequal, and rational. Why is it rational? Because your delta is a squared rational or a perfect number. So if you calculate your delta and you find that your delta is not a squared rational or not a perfect square. So if you calculate your delta and you find that your delta is not a squared rational or not a perfect square, it means that your roots are irrational. So they are actually irrational because your delta is not a perfect square. They are still real, but they are irrational because your delta is not a perfect square. So, but we know delta is greater than 0. It's just that that number is not a perfect square. Then they are irrational. Okay, how do we know on our graph? So with the real roots, it can just be more than one root, right? Normally there are more than one root. You can see here you can have an answer 0, maybe here you can have an answer 1. So these two answers, they are their roots, right? With the 0 and 1, they are roots. So we can actually get the nature of these roots by just looking. So we know that they are real, because it's this 0 and 1 is real numbers. So you can see also this side is when you just have two roots like that. They are on the number line. Obviously they are real. So if you're just given an equation, you just calculate delta and you just check your delta How is it? Is it greater than 0? Is it equal to 0? Is it less than 0? Then you can conclude on your nature of the roots. Okay, so let's just really quickly look at different examples in order to help you to understand this. Okay, grade 12s and grade 11s. Let us look at example number 1 and yeah, let's start. It says determine the nature of the roots of each of the following equation. It's only one equation. I'll just use one equation in this example. You're given x squared plus 3x is equals to minus 2, and they want to know the nature of the roots of this equation, right? So the only thing that can help us to determine the nature of the roots is delta. Don't forget, it's delta. And we know that delta is equals to b squared minus 4ac, right? So in order to calculate delta, we must have a quadratic equation in the standard form x squared plus bx plus c is equals to 0, right? So that we can calculate delta. So if your quadratic equation is not in this standard form, you first have to make sure that you make it in that standard form. Then you can calculate your delta. Then after calculating your delta, think of the conditions of delta. Then you can conclude, okay, my roots is real, my roots is non-real, my roots is imaginary, something like that, right? So that's it, or my root is equal. So what I'm gonna do is I will ensure that my equation is in this standard form, x squared plus bx plus c, right? So you can see it's x squared plus 3x is equal to minus 2. So I'll first make it in that standard form. I transpose 2 to the minus 2 to the other side. It will be x squared plus 3x plus 2 is equal to 0. Okay, now my quadratic equation is in that standard form. Then I can calculate my delta. Delta is b squared minus 4ac, right? So I must have a, I must have b, I must have c, right? So in order to calculate that delta there. So my a is the coefficient of x squared, that is the number that is behind x squared, it's 1. My b is the coefficient of x, the number that is behind x is positive 3. My c is the constant, which is 2. Then I can go and substitute and calculate delta. My b is 3 squared minus 4. My a is 1 and my c is 2, right? So 3 squared is 9, minus 4 times 2, it's minus 8. So it's gonna be 9 minus 8, which is 1. So my delta is 1. Let me just write it clearly. Delta equals to 1, right? So what can we say about this delta? This delta is greater than 0, right? My delta is greater than 0, right? It means that what about the roots? The roots are real, right? So the roots are real because delta is greater than 0, right? Then now let us look, because for real roots we have two further conditions. They can be rational and they can also be irrational, right? You check whether your delta is a perfect square or not a perfect square. Check, my delta is 1, right? And if I take a root of 1, it's 1. And if I say 1 squared is 1. So 1 is a perfect square, right? So it means that my roots are real and also what? Rational, right? And also rational. My roots are real and also rational, right? My roots are real and also rational. So that is the final conclusion that we can make. Roots are real and rational. So that's it. Okay, let us move to another example. Example number 2. They say show that the roots of x squared minus 2x minus 7 equals to 0 are irrational. We want to see whether these roots are irrational. First step, check whether your quadratic equation is in the standard form x squared plus bx plus c is equals to 0. So if it's in that standard form, you just calculate delta, because delta, or the discriminant, will help you to determine the nature of your roots. So we're going to calculate delta. The formula is b squared minus 4ac. So our b is the coefficient. Okay, let me just quickly write down these values here so that we cannot make any mistake. My a is the coefficient of x squared, and the number behind x squared is 1. My b is the coefficient of x, the number behind x is -2. My c is the constant, which is -7. So with my b, I'm going to put -2 squared -4. My a is 1, my c is -7. So I'll just quickly use my calculator and then calculate this this value of this expression. Then with my calculator, I'm getting an answer of 32. So I can see my delta is greater than what? Than 0, right? So we can see the roots are real, but the equations, they show that they are irrational, right? So we can see that delta is equals to 32, right? And we can see that the root of 32, it's a number with a it's sort of like it is decimal. It's gonna be 5.65685 going there. You can see that this number 32 is not a perfect square. 32 is not a perfect square. 32 is not a perfect square, therefore the roots are irrational. So you have shown them that, okay, 32 is not a perfect square as my delta, therefore my roots are irrational. But if it was like a number that is a perfect square, we were going to say the roots are rational. But then we got something that is not a perfect square, therefore the roots are irrational. Okay, let's now move to example 3, and they said, for which values of k will the roots of 6x squared plus 6 is equals to 4kx be real and equal? So they're giving you the condition for delta now, for which values of k. But now this is a different problem where you have to use your knowledge of the nature of the roots to get an unknown in your quadratic equation, right? So before answering this, let's just write it in a proper standard for quadratic equation. So we're going to transpose 4kx, so it will be 6x squared minus 4kx plus 6 is equal to 0. So now our equation is in the right standard form, x squared plus bx plus c is equals to 0. It's perfect, but then we need the values of k, this unknown, for which the roots will be real and equal. What is the condition for delta when we say the roots are real and equal? We said delta must be greater or equal to 0. Why are we including equal? Why are we including that one? It is because they said equal, right? So that's it. Our delta must be greater or equal to 0, right? But we know our delta is b squared minus 4ac must be greater or equals to 0. So we're just going to calculate our delta. We know our a is the coefficient of x squared, that is the number behind x squared, it is 6. Our b is the coefficient of x, that is anything that is behind x, and we can see it's minus 4k. Be very careful there. Minus 4k is your b, that is the coefficient of x. Then our c is the constant, which is positive 6. We can just go and substitute to be minus 4k squared minus 4. Our a is 6, our c is also 6, greater or equals to 0. Remember, we need the values of k for which the roots are real and equal. Hence, I'm using this condition to just solve for those values of k so that it might give us the answer that is real and equal. So minus 4k squared is gonna give me 16k squared. Then minus 4 times 6 times 6 is gonna give me minus 144, greater or equals to 0. It's quite a long question and an interesting one. So this is now a quadratic equation. What I can do, I can go on the number line and actually get my critical values, right? So my critical values may be using the quadratic formulas. So if I need the critical values, sorry about these critical values, I'm going to use my quadratic formula. K equals to minus b, we have 0, we don't have b, plus or minus root of 0 squared minus 4. Our A is 16, our C is minus 144 divided by 2 into A, which is 16. So I just want to solve for the critical values using my quadratic formula, because this is a quadratic graph. So using my quadratic formula, I'm going to get an answer of, let me check, plus and minus 3, plus and minus 3. So we have minus 3, we also have plus 3, because it's a quadratic formula. The value of A is positive, then it's a smile, then it's like that, then we check. So you take this line as 0, and then you check where your graph is above or equals to 0, because this line is 0, because the y-intercept is 0. Where your graph is greater, it's when it's on top, above 0, greater or equals to 0. It's that interval. So the values of k we can see is when k is less than, because here we are moving backward, less or equals to minus 3. That's the answer. Or it is when we are going this side, where the graph is greater than 0, is when k is greater or equals to 3. So these are our final answer. So it was, you see, it was a combination of knowledge of nature of the roots and also how to solve inequalities, right? So I'll just upload also the link. I'll just post the link on the description box below of the video where I did algebra and how you can solve inequalities. So that's where you'll really understand where does this comes from, and then you can just use this method to get the final answers. But the big deal here is we had to find an unknown. Given that our roots are real and equal, we had to know this condition and use it to solve that unknown till we get this answer. It's when k is greater or equals to 3, or when k is less or equals to negative 3. Okay. Okay, grade 12s, let us continue. We are looking at example 4, and the question say, show that the roots of x plus h into x plus k is equals to 4d squared are real. Very important statement, are real for all values of for all real values of h, k, and d. What does it mean when the roots are real? How do we know? We know that if roots are real, our delta must be greater or equals to 0. So in other words, this question is asking you to really prove that really your delta is greater or equal to 0. That is what it means when it shows that the roots are real. So we know that before calculating delta, we have to ensure that our quadratic equation is in this standard form, ax squared plus bx plus c being equated to 0. So basically what we'll first do is we are going to rewrite or simplify this equation in such a way that it can be in the standard quadratic formula form, right? So let us go and do that. We take x times x, then it will give us x squared, then x times k, it will give us what? Xk. Then h times x, it will give us xh, plus h times k, it will give us hk. So basically what I did, I just removed the brackets and just expanded that expression there, being equated to 4d squared, right? So let's see if we can take that one the other side. It will be x squared plus, but we can see here that there's a common factor. Can you see there's a common factor of x, right? So if we remove x, we'll be left with k plus h, k plus h being multiplied by x, because x is the common factor. Then this side is hk. If we take 4 to the other side, is minus 4d squared being equated to 0, being equated to 0. So now you have written your quadratic expression in the standard form of x squared plus bx plus c. Now you can calculate your delta, right? So now you can calculate your delta. You know that the equation for delta is b squared minus 4ac, right? So let us look for a, let us look for b, let us look for c, so that we can just simply substitute and get the answer. Our A is the coefficient of x squared, which is 1. Our B is the coefficient of x, which is k plus h. Very important. Quite a tricky question, but that's it. Coefficient of x, k plus h. Then the constant, it's basically this one. It has no x and all that. So it's hk minus 4d squared. That is our constant. So let's go and calculate our delta. Our delta is b squared. What is our b? Is k plus h squared minus 4. What is your a? Your a is 1. What is your c? hk minus 4d squared. Very good. Okay, delta. We can expand this one to be k plus h multiplied by k plus h. So I'll just do that quickly. It will give me k squared plus 2kh plus h squared, right? So when I expand it, so minus 4 times 1 is minus 4, minus 4 times hk, it will give me minus 4 hk, right? So minus 4 multiplied by 1 multiplied by minus 4d squared, it will give me positive 16d squared. So I'm just doing that quickly because of space, and we can just really see how we can solve this, right? So let us add the like terms. If there are any like terms, we can just group them together and we can see what will happen next. So k squared, no like term, it will just remain k squared. 2kh, you have a friend, it's minus 4hk, right? So 2kh minus 4hk, it will give us minus 2kh, right? It's fine. H squared, no friend, and then 16d squared, no friend, right? So now let's simplify this one and see how it will go, right? So what you can do in order to simplify this is you can see that here, just take a look at this one. Those two can be factorized, right? They can be factorized. Even this side, 16d squared, it can also be factorized. So delta will be equals to, how can we factorize this, right? So it's the same as saying maybe k minus h squared, right? So if you say k minus h squared, you expand it, it will still give you k squared minus 2kh plus h squared, right? So we factorize that one. Let's go to the other side, and this one will just be 4d all what? All squared, right? So we are writing them to the exponent 2 because we are really trying to prove that our delta will always be greater or equals to 0, right? So let's prove it. So our delta is made up of two terms. Let me just write this properly because I can see it's not really that nice. Then what we did is we wrote those things to be like squared, right? So that we can show that no, there's no way for any real values of k, h, and d, if you substitute them there, there's no way those things are going to be negative, right? There's no way they're going to be negative because anything squared is positive. So we can just conclude k minus h squared will always be greater or equals to 0. And also 4d squared, because it is squared, also it will always be greater or equals to 0. Therefore, this proves that really our delta will also always be greater or equals to 0. So therefore, we have proven that the roots of this equation will always be real. So it was quite a challenging question, but that's how you approach it. You just try to show them that those things will always be squared, meaning they won't be negative, they will always be above 0, meaning your delta will always be greater or equals to 0. Therefore, we can conclude the roots of that expression, of that equation, sorry, it will always be real. Okay, great stuffs. We are still continuing with nature of the roots, and right now I just want us to focus on higher grade 2002 November IEB question. As you can see down on the slides, we got this from Siavula. You can visit their site www.siavula.com. Okay, so the question says you are given x squared plus bx minus 2 plus k into x squared plus 3x plus 2 is equal to 0. And they say so that the discriminant is given by delta is equal to k squared plus 6 bk plus b squared plus 8. So this is quite a simple question, but at the same time it's quite challenging because we are sort of like given this expression, and we know that before calculating delta we must write our expression in the form of x squared plus bx plus c being equated to 0. Very important. So from that expression, what we are going to do is to first write it in that standard form. Then after writing it in that standard form, we can then calculate delta. Then after calculating delta, we can simplify it till we have proven that really our delta is that one. Okay, so yeah, let's get to it. It's x squared plus bx minus 2 plus, so we know we can remove by k times x squared, it will be kx squared, then k multiplied by 3x, it will be k3x, right? K3x, then k multiplied by 2, it will be 2k, being equated to 0, right? So now we can just group the like terms together. We have x squared. Does it has a friend? I think it has a friend, which is plus kx squared, right? Because they are like terms. Then let's look for other like terms. As you can see, we have bx. This is our bx. Its friend is k3x, right? So we're just gonna put it there to say plus bx plus k3x. Do we have another one? Let's check. We have these ones which are sort of like our constants, right? So it's minus 2 plus 2k being equated to 0. But don't forget, we have to write it in ax squared plus bx plus c being equated to 0, right? So if you check here, it's not actually in this standard form, but we know we can write it in a way that there will be a multiplied by x squared, right? So we can simply take our x squared as the common factor. Then what will be left? It will be left with 1 plus k. So now it's in that standard form. It's our a x squared, right? So that's it. So let me just write properly. So it's that. Let's go here in the middle also. We're gonna take our common factor of x, then we'll just be left with our b, right? So our b, it will be like, okay, when we remove x as the common factor, we'll be left with b plus 3k, b plus 3k, b plus 3k. Then our constant is just minus 2 plus 2k equated to 0. Great. Now you have written your quadratic equation in that standard form. Then you can now check your value for a, b, and c. A is the coefficient of x squared. That is the number behind x squared, or anything behind x squared is 1 plus k, right? Good. So our b is the coefficient of x, which we can see is b plus 3k, right? Our c is our constant, which is minus 2 plus 2k, right? So now we can calculate delta. We know the formula for delta. Delta equals to b squared minus 4ac, right? What is our b? Our b is b plus 3k squared minus 4. What is our a? Our a is 1 plus k. What is our c? Our c is minus 2 plus 2k. Then what's left is just to simplify in order to prove what they need, right? Okay, let's go and simplify b plus 3k. If I expand it to be b plus 3k multiplied by b plus 3k, if I simplify it, it will just be b squared, then my plus to be b squared plus 6bk plus 9k squared, right? This one, when you just simplify it. Then this side we have minus 4. It's just gonna take some space a bit. Minus 4 into, if I simplify those, it will be minus 2, because it's 1 times minus 2, 1 times 2k, it's plus 2k. Then k times minus 2 is minus 2k. Then k times 2 k, it is going to be 2k squared, right? Then we can just simplify. So our delta will be b squared plus 6bk plus 9k squared minus 4. We have minus 4 into let's see, 2k minus 2k, they cancel each other. We're left with minus 2 plus 2k squared. We can just remove by minus 4. Then our delta is b squared plus 6bk plus 9k squared. Minus 4 times 2 is positive 8. Minus 4 times 2k squared is minus 8k squared. Then we can group the like term and see our delta if it will give us that. So we can see we have 9k squared minus 8k, right? It will give me k squared, right? It's k squared. Then we have plus 6bk plus b squared plus 8. Then if you check, we have proven that really our delta is the same as that one, k squared plus 6bk plus b squared plus 8. So basically what we did is just you writing that expression, that equation in the standard form, x squared plus bx plus c. You must be able to define your a, your b, your c, substitute on your formula, then express your delta in the way that they need it. Okay, let's proceed. Okay, now let us look at number B of the same example. We are given that equation. Don't forget that in the previous equation, we managed to show that our delta is equals to what? We managed to show it's equals to k squared plus 6bk plus b squared plus 8, right? Don't forget that we just proven this in the in that previous question. So now they are saying you are given the same equation. Then they're saying if b is equals to 0, discuss the nature of the roots of the equation. Okay, so we know our delta is k squared plus 6bk plus b squared plus 8, right? So they're saying b now is equals to 0. Can you please discuss the nature of the roots? What will we do? We are going to first calculate our delta, then we're gonna discuss it from there. So our b is 0. Where there is b, we're gonna put 0, and then also here 0 squared plus 8. Then you will see your delta will be k squared. 0 times 6 times k to just be 0, so it's out, right? It's 0 plus 0, so 0 plus 0 is still 0. Then we'll just be left with k squared plus 8. K squared plus 8. What can we discuss about these roots? Your root is k squared plus 8. And remember, the equation say k must not be equals to -1, right? So it's just k squared plus 8. We can see that our delta, any value for k that we can substitute there, will ensure that this answer always be greater than 0, right? But it cannot be equal to 0. Why are we saying always greater than 0? It is because any value that you can substitute, -2, if you put it, any negative number, any positive number, this equation will remain above 0. Why is it like that, right? Okay, let me just show you. Anything that is squared will never be negative. So we can simply say, we can see our k squared will always be greater or equals to 0, but k squared plus 8 will always be greater than 0. It won't be equal to 0 because we are already adding 8 there, and this one is always positive. So k squared plus 8 is greater than 0, therefore we can conclude that delta will always be greater than 0. What we can now discuss the nature of the roots, right? So let us discuss. It means that therefore the roots are real and unequal, because it's not equal to 0, but it's just delta greater than 0. the roots are real and equal. So that is what we can say about those roots. Okay, let's move to C. We're still on the same equation. Don't forget that we have calculated our delta is what? Is k squared plus 6bk plus k squared. Is it k squared? No, it's b squared plus 8. Yeah, so B says question C now. It says if B is equal to 2, find the values of k for which the roots are equal. B is equal to 2, find the values of k for which the roots are equal. So where there is B, we are going to substitute what? 2, right? So now let's go where there is B, we're just going to substitute 2. Then we have k there, where there is b is 2 squared plus 8, right? So let's simplify. It's going to be k squared, 6 times 2, 12, 12 times k, 12k, 2 squared, 4, 4 plus 8, 12, right? So that is now our delta. So we need the values of k for which the roots are equal. What is the condition? When the roots are equal, it is when delta is equal to 0, right? Notice it is when delta is equal to 0. So we're going to equate delta to 0 and solve for k. Great. So our delta is 0. Then we can just simply go there and solve for our k, right? Let's see if we can factorize this. Can we factorize this? Is it possible? It means we're gonna use the quadratic formula, right? Let's use our quadratic formula. K equals to minus b plus or minus root of b squared minus 4ac divided by 2a, right? So what is your b? It's the coefficient of k, it's minus into your b is 12 plus or minus root of 12 squared minus 4, our a is 1, our c is 12, divided by 2 into our a is 1, right? Great. So k will be equals to, let me quickly use my calculator, minus 12 plus or minus root of 12 squared minus 4ac divided by 2 into a. Then I'm getting an answer k equals to minus 1,10. Just round out to 2 decimal place. Or k is equal to, let's try when it is like this, and then we're getting k is equals to minus 10.90. When I round off to 2 decimal place, minus 10.90. So those are the values of k for which the roots will be equal, right? So we just used the quadratic formula there. Okay, let's look at D now. We're still on the same equation. Don't forget we have calculated that our delta was b squared. Was it b squared? It was k squared plus 6bk plus b squared plus 8. Let's not forget. So they're saying show that k squared x squared plus 2 is equals to kx minus x squared has non-real roots for all the real values of k. So now they're just giving us another sort of kind of equation, right? So from this equation we have to ensure that it's in the form ax squared plus bx plus c being equated to 0. Then we can now calculate delta and really check our delta. If it will be less than 0, then we would have proven that really they are real, non-real roots or imaginary or undefined roots in that equation. So we have k squared x squared plus 2. I'm just going to transpose those to the other side because I want to write it in the standard form for a quadratic equation. So it's minus kx plus x squared, right? Let me group the like term being equated to 0, k squared, and this one it just be k squared x squared plus x squared, right? Then followed by that one minus kx plus 2 is equal to 0. then I know here I want to know my value for a, right? When I take out the common factor of x squared, it will be k squared plus 1 minus kx plus 2 is equal to 0. We can go and determine value of a, b, and c. My a is the coefficient of x squared, which is k squared plus 1. My b is the coefficient of x, which is minus k. Then my c is the constant, which is 2. Therefore, delta is b squared minus 4ac. Then I can go and substitute. What is my b? It's minus k squared minus 4. What is a? It's k squared plus 1. What is c? Is 2. Right? Minus k squared, it is k squared. Great. Right? So minus 4 times 2 is minus 8. Minus 8 times k squared minus 8 k squared. Right? Then minus 8 times 1, it will be minus 8, right? So that is our delta. That is our delta. So we have to show that k squared, that equation will have non-real roots, that is undefined roots, right? We have just calculated our delta now, right? So after calculating our delta, we really need to show that, okay, it's not really yet complete. Let me just complete it. Then it's k squared minus 8k, right? It's gonna give us what? Minus 7k squared minus 8. So this is our delta. So if you check your delta for any real value of k, your delta is always gonna be negative. Oh, why is it gonna be negative? Okay, someone might argue, okay, k is squared, why is it gonna be negative? Okay, look, your k is squared, right? Inside there, your k is squared, so it means your k will never be negative. It will always be positive. For any real value of k, when you substitute, that thing inside will always be positive. But because it's being multiplied by minus 7, being also subtracted by minus 8, it means it's going to remain negative, right? We can prove it. If we say minus 7, we substitute k equals to 2, then it's 2 squared minus 8. You see, minus 7, 4, minus 8. You see now, minus 7 times 4 is going to give me minus 25. Is it minus 25 or minus 21? Let me check. Minus 7 times 4 is minus 28. Minus 8, look at this. Minus 28 minus 8, then it's minus 36. You see, for any value of k, that thing will always be less than 0. It will always be negative. So we can deduce that, okay, our delta will always be less than 0. Therefore, the roots will always be non-real because delta is less than 0. Okay. Okay, great. So these are some of the references that were used in creating this content. We used Siavula. You can visit their site at www.siavula.com and you can just register your account and start learning there. So what is really interesting about Siavula, they have some interactive practice questions, and that has immediate feedback. So it's very, very effective. You can visit their site and just learn more about nature of the roots and other maths and science content. This marks the end of this lesson. Thank you very much for watching. Thank you very much for supporting this channel. Thank you for our subscribers and all people who just drop their comments and motivating us. Thank you very much for that. And that's all for me. Don't enjoy the rest of your day. Thank you.